be half and half. First up, we have Nicolas. He's a web developer working on Firefox DevTools, mostly on the console. That's what we want people to know. He's going to give you a tour of the Firefox DevTools. I'm going to leave you to it. Enjoy.
Okay, thank you. Do you hear me well? Yeah. Okay. So, hello everyone. I'm Nicolas Chalob. I'm a member of the Firefox DevTools team, and I'm working on the console for about 2 years now, and a bit less than a year as a Mozilla employee. So today I will talk to you about what the Firefox DevTools and what we added in 2017. So the DevTools team is rather small, about 15 people spread across Europe and North America. And what we have been up to in last year. So basically a lot, and I will try to not just have a dumb list of new features, and that will make you fall asleep at this hour. So we have this website we use to send contributors to when they want to work on the DevTools. It shows you the list of the bugs we have on the DevTools, and you can filter them by tools and pick if this is a good first bug to work on, or if they are a mentor to work on this bug. So there are a few issues on this site which I want to fix using the Firefox DevTools. And so at the same time, we'll show you a feature we added last year. So let's start with the design of this site using the inspector. First thing you notice when you open the inspector is the new colors. So it's a bit hard to spot here, but we added the new Photon design system, which is the design system Firefox uses for Firefox UI. So the first issue I have is on this page, I have a list of unordered links, and I do have some space between my lines. And I don't know why, because I didn't have any padding or margin. And so when you open the inspector, you can see that there is a little button with a dot inside, which means it's a white space only text node, which takes 3.54 pixel. So it might be interesting when you're designing something to know what there is some space between elements. And if you want to know why there is white space node, basically it's the way you alter your HTML code. You can read Patrick Brossett's post about it. Another thing that bothers me here is the look of the animation. So you can see the Firefox logo spinning when we are searching for a list of bugs. We are rotating it, and it's a bit linear. And so maybe we can do things better. So to work on the animation, first I need to trigger it. So I can do this in the UI by just trying to select a tool and see the logo spin, but it's a bit limited since when the bugs are coming, the animation stops. So I need to find a way to add the loading class to the body, which triggers the animation. So there is a button in the rules view, which is really hard to spot here, but it's the .cls button. And when you click on it, you will have an input where you can add a class, and then it puts it in a toggle with a checkbox behind it. And you can toggle it and see the different state between loading and not loading. And this is not just limited to only one class. You can have multiple ones. So in this page, we have a dark mode. And by doing that, you can see how the dark and light mode looks like with the animation or not. So let's go back to the animation. I made some changes, tweaking the rules. And now I have two properties animated, which is transform scale and opacity with different easing. So you can see the curves looks differently because they don't have the same easing function. And I can hover those curves to see the animation properties, or I can hover a specific keyframe. So you see the little circles in the bottom. If you hover them, you can see the property at this given time in the animation. So the animation looks fine to me now. Let's move to something else. Another issue I see on this page is it could be better for first-time contributors. We used to send people here and say, OK, find the bug, but it's a bit weird. We have some links at the top to say, okay, how to install Firefox and build it, stuff like that, but it could be better. So maybe we can try to have a landing page for first-time contributors, and so they have a better sense of what the page is about. So here I just built an unstyled landing page, and we are going to set up some rules using the inspector to make it better. So first we want to have a nice branded gradient colors. So I have these CSS custom properties which are extracted from the Photon design system. See -- blue 50 and so on. So I can go to the rule view and type my gradient like linear gradient and parentheses and then -- and it will automatically give me a list of all the different variables I set in my page, which is quite nice. And then I can hover a specific variable in my rule view to see what its value is. So here I can know that -- white is white. Very helpful. For a more branded look, I wanted to use the Zilla font on this page. So Zilla is the font that is used on the new Mozilla logo. And something that landed just a few weeks ago in the inspector is that the font that is being used on a given element is underlined. So here you can see the Zilla slab font is underlined, which means it's the font you are being served. And it's really nice, so you can spot if you are missing a font, if it's not installed on your computer, or if a remote font wasn't able to be downloaded, for example. Which makes me think you can go to the font panel and check the font properties. And you can even enter custom text to see what the font looks like. Like here, I just put Firefox Fast for Good. And so this is the first, it's a system font, which means a font that is installed on my computer. But if you have a remote font, you can see other properties like the font face declaration. So now let's get to the bigger part of the inspector this year. CSS Grid is a set of new properties that let you declare layout in a much simpler way than we used to. If you are not familiar with it, you can check the work of Jane Simons, Rachel Andrews, and Wesbus, just to name a few, who put terrific resources online to learn CSS Grids. And by the way, all my slides are built using CSS Grid. So I want to use it as well for my landing page. So let's put display grid on the container. And then you can see there's a little button next to it, or you should see it. And when it's clicked, it shows the boundaries of my grid elements. It's hard to spot now, but then I can change the color of these boundaries and put it a white, for example, so it might be more noticeable. Yeah, not so much, but you can see some lines, and it's all about the boundaries of your grid. Then I'm going to share a little secret with you. We are working on a way to have 3 panels at the same time on the inspector. This way you can see and set things even more easily. So here I open the third panel, and I can see both my rules, where I will put my grid properties, and the layout panel, where the actual layout of my grid is. So I can declare a simple template of 4 columns. So it's grid-template-columns, and then some syntax you don't have to learn now. But then you can see both the content and the layout panel are updated in real time. And in the layout panel, I can hover those columns, and it's highlighted directly in the content page as well. So you can spot where your things are. And then I can just play with my element and place them in the grid. So you see those little kind of buttons on the content page. It's the column and lines number. So when I'm on an element, I can then place it using those lines as references. For example, my title, I put it starting at the first column and ending at the -1 column, which is the last one. And I can do the same with the other elements. So the logo, I just put it in the second column, which is now is good. And the links that are on the right, I want them at the bottom. So it's nice. And then I just paste something I saw on internet for using a flexbox property that's looking nice. And if you are like me and are confused by flexbox, we are also working on the flexbox inspector. So you might be able to see it during this year. One last nice trick in the grid inspector. In my CSS, I declare some areas so I can name areas instead of dealing with line and column numbers. And so there is a little checkbox in the UI which display area names. And when clicked, you can see the names are directly in the config page. And you can see which cells has which name. So things are going pretty good, I think, but we can do even better. So there's an experimental property called shape outside, which lets you define non-boxy shape for content to float against. So basically here I have a float div with a shape outside set to circle. And then I have a little button next to it. And if I click it, it will show me the shape, the circle shape, and then I can move it. So the video is over, but there is a circle and I can move it around or grow it, and you see the content flowing at the same time as I manipulate the circle. It's pretty rad. And there are other type of shapes, like polygons, and we do have a shape editor as well, so you can add points and move them and see the content flow across the screen. Okay, so I think we have a good landing page now. So what's next? I heard of a small library, it's called React, made by a small company. So I want to try it out on this page. And because we are building something with JavaScript, I think we have to use the debugger. So last year we shipped a new debugger using React and Redux, which allow us to iterate quickly and also have lots of contribution because people are used to use those technologies. So something in my page isn't working. I can't have the list of bugs loading for some reason, and I don't know why. So I opened the debugger and I'm a bit lost because I don't know what to look after. And there is a little button, which is a question mark. When clicked, show me the shortcuts on the app. And it tells me I can do Command P to search for a file, so okay, let's do that. But then I remember I don't know which file to look at, so maybe let's try something else. I know something is wrong with an input because it's when I click the input that something must be loading. So I tried to search the entire project for input, and I got this nice view of all the input iteration, like in Sublime or in VS Code. But there is multiple of them, and I don't know which one to choose. So another way to see what's happening for events is to look at the inspector and spot the event bubbles on nodes. So here I inspect the input, and I see a EP, little icon, and when click, I can see there is multiple events attached to it, and the one I'm looking for is unchanged, and I can then jump to the debugger using that. Okay, I'm now in the debugger. That's cool. Looking at the right file, or maybe not in the screenshot, but I am. And I can see a nice source tree. We used to have only a list of scripts in the old debugger, which was really hard to navigate. Now it's really a nice tree, and you can even see that we are using source map, and we have the big bundle file, but everything is shown under Webpack to show the original files and original paths, so I can navigate like I do in my editor, for example. And you can also collapse things and expand a directory with all that click. It will expand the whole directory. It's pretty nice. And now that I'm in this file, I can have a look at the outline view. So in the left, I can see there is a class, which is component sidebar, and a list of functions. And when I click on a function, I can navigate to it in the debugger, which is cool to just navigate through a file. This one is pretty small, but you can have a huge file, and it's very helpful. By the way, it's maybe hard to notice from your sit, but do you see how nice the code looks? Like, I use JSX, and it's all highlighted and nice and feeling very crisp. It also works on TypeScript, CoffeeScript, and even C files. We used to highlight everything, basically. And when working with source map files, I can just jump to a generated location, so I can look how my code is being generated in this huge file of more than 20,000 lines. Okay, back to the faulty function. So I set up a breakpoint in it. I selected a tool, and now we are paused in the debugger. And I can see the stack trace on the right, which is quite nice because all the React calls are groups into a single items. And I can expand it if I need to see React internals, but most of the time I don't care about what React is doing. So they are nicely grouped. It's not only for React, we do it for Redux as well, and Immutable, and other libraries we support, like maybe 20 of them. Another nice thing is that even if I'm in an original file and the even variable has been renamed to E, I can still evaluate event in the watched expression and access properties on it. So I'm not restricted by source map having renamed my file. So basically, when you debug something, it involves a lot of clicking on step in, step out, step over button to get to the actual point where you see the line you're interested in. And it might be cumbersome. So now you can click on the gutter on the line you're interested to go to when you are paused and select continue to here. So it will jump to directly to the expression you wanted to go to if it's in the right path. So I know what was the problem on my function. Basically, it was this is undefined, and it's because React asked you to bind all your methods so it can work properly with events. So here, I just bound my method in a constructor. And do you notice what happened? It's like I reloaded, and breakpoint was on line 14, and when I reload, it's on line 18. And I did not do anything for that. So that's because we have something in the debugger called Ast Breakpoint. So breakpoint is not located anymore just on a simple file plus line number. It's It's referenced also by an Ast location, which means here in this case, it's the variable, the search bug variable assignment in the onComponent change method. So when you reload, we try to spot that very specific instruction and not just a line number. It's very nice so when you iterate over your code and try to fix bug, you don't have to deal your breakpoint on or see the breakpoint being on a totally wrong place and pause when you don't want it to pause. And I tried to integrate WASM on this website, but I fell short of ideas. So I just put a nice picture of C Fibonacci function running in the browser, and it's nicely formatted and highlighted, and you can even pause on it. We also have Rust support, I think, but we don't have a highlighter for now, so didn't show it. So finally fixed my React bug. Great. So one thing that I want to fix now is the contributors list. So on the right, you can see there is a list of people. This is the list of people who fixed the bug on Bugzilla during the last 30 days who are not on the staff. But we also have code which are not on the Mozilla Central repo. We do have repository on GitHub under the DevTools HTML organization. So maybe it would be nice to see contributors to these repos show up here also. So I made a call to the GitHub API to get all the repos we have for the DevTools HTML organization. And I get something back, but I don't really know how to operate from this point. So let's see what we can do with the console to better understand what I can do with this data. This year we also shipped a new console with a cleaner design, so you can really focus on the logs. Yep, sorry. And it has the same colors as the rest of the DevTools, which are pretty nice. You can also see that the first log option has been moved to the UI. So if you click it, when you reload the page, you won't see your logs disappear. So previously, I had filtered off error messages. I don't really know why, but. And you can see the UI that it tells me that some messages were hidden. And there's a UI that can, a button that can click and which will reset the filters to the default state, which could have been helpful when digging my React bug. Because here I see an error message taking me to the correct JSX file. So all the stack trace is nicely source mapped. And there is even a learn more link, which will take me to the MDN page, so I can have a better sense of what the error is. And since we are in the console, I can see I added Redux Logger to my page. So basically, when you're using Redux, it spawns all the action you fire and in a nice way. And it looks nice, and it's because of two things we added in the console last year, which is console.group. They were already supported, but you couldn't collapse a group, which was making them almost useless. Now you can expand and collapse them as you wish. And this allows us to support console.group collapsed as well, which creates a group that started collapsed by default, like the big group you can see in the image. The second thing we added was style console.group. So we already had style console.log, but not for group. This is now fixed. And if you don't know style console.log, it's a nice little thing that lets you set parts of your messages, like style parts of the message, and using CSS properties. So here we have console.log, %c hello, %c word, and color red and color blue. And basically it will output a red hello and a blue word, which is nice. And you can build fun little helpers like I did to have a rainbow logs in your console, because we all need this. So I made the call to the GitHub API to get all the repos on the devtools.html.org. I paused the debugger when the etc call was over, so I can expect what was returned to me in the JS results variable. The first thing you may notice is that you can inspect the object directly in the output. So yeah, like Chrome does. But we are also working on the console sidebar. So you can pin an object to the right and still see your messaging coming into the console. So the results I get from this API call is pretty big. So maybe I want to try to use console.table on it. Basically, console.table puts a nice little table on the output if you are using it on a large object or an array, a map, a set. And it shows in a nice way in the console. But this is still not ideal for my needs. And usually what I do when I have to deal with large amount of JSON data, I just copy it and then display it in my editor. So you can copy an object right into the console by doing right-click on an object and then copy object. It will try to JSON stringify it if it can't, if they are not proto or something like that. And then you can paste it where you want. Very helpful. And since we are talking about some API function, you can see a recap of all the APIs we have. So you know probably console.log, but there's also console.error, console.warn, console.info, and console.debug. There are different levels of log that you can filter in the console output. And then we talked about there is console.dir of an object. It will auto-expand the object in the console. We talked about console.group, console.time, and console.timeend. Will tell you how much time was spent between those two calls. So you can measure a function call, how much time a function call was taking. Console.count will output an incremented counter each time it is called. So it might be helpful in a console to know how much time it is called. Console.assert takes an assertion and then a message, and will only output something into the console if the assertion is false. Like basically a test in your console. And console.clear just clear the output. And yeah, I have some little tricks that might be helpful. So when you are in the console input, you can type inspect on the variable, and it's basically an alias for console.dir. bit shorter. You can concatenate multiple parts of a message, like console.log a, the variable a, comma b, the variable b. So you will have a and its value. Or you can use the EF6 shorthand, which is declaring a small object will have a and b properties and e and b values, which is very helpful to spot which variable is which one. And you can use console.log in conditional breakpoint in the debugger. So if you right-click in a gutter on the debugger and add conditional breakpoint and type console.log, your variable in it, the console.log will be executed, but since it returns undefined, it won't pause the debugger. So if you don't have access to the source, for example, or if you don't want to add another console.log, you can do it in the debugger and it will show up in your console, but it won't pause the debugger. Okay, one last thing I wanted to show you in the console is that we can display network logs as well. So you have to enable the filter, the XHR or request filters. And basically we share the same components with the net monitor. So you should have a consistent experience between those two tools. And here in the console, you can even click on the status code. So here you can see a green 200 status code. And if you click on it, it will navigate you to the MDN page with the 200 code and explain to you what it is. Okay, so I saw the extra call to GitHub, and let's switch to the net monitor to fully inspect it. The net monitor was also rewritten in React and Redux and have these nice Photon colors. There were some improvements in the UI, so you can directly persist log and disable the cache right into the net monitor. When you click on the network country, you get to a panel we call the details panel, where you can inspect more deeply a network call. So here you can see all the request and response headers, and you can even click the question mark icon behind them if they have some. And it will take you to an MDN page explaining you what the header is, which is really, really helpful. You can also go to the stack trace panel, which shows you the stack trace that led to this call. So if you have a fetch call that do a network call, you can trace it, and it's nicely source mapped. And here in the stack trace, I can see my accent.js file being called. And I know I can have a look at that if I want to see why the call was triggered. And in the net monitor, if you already found something, the log that you were looking for, you can pause the net monitor. So it won't show up, it won't show you any more network logs happening. The network logs will still happen. The browser will still make the network logs, but they won't show up in the UI. So you can concentrate on what you are looking for. So here I want to inspect my GitHub call, but maybe I have a huge list of requests and I don't know how to spot it. So what I can do is use the filter input to filter in a specific domain. So if I type domain colon, you can see it's already auto-completed with two domains, like the different domains I have in my log, which are github.com and bugzilla.org. And I can also filter by negative filter, so I can type minus domain column, and this might be helpful for tracking third parties code. Like if you're on a news site and want to see all those nasty ad trackers, you can do that with negative domain. And if you still have issues finding what you want, you can combine multiple filters. Like I want the github.com domain calls and made by fetch, for example. So you can type calls fetch. So I found what I was looking for, and I can check the parameters of these network calls. So you can see that repeated parameters are nicely grouped. So here you can see the components, for example. There are multiple of them, but they are grouped under a single node, which is quite handy. And the most important thing for me is the response panel. Since the response has a proper content type header, I can directly inspect it as in the console, which is really helpful. And doing this, I wonder how many repos the Mozilla organization on GitHub had. So I used the edit and resend features, which allow you to modify the URLs and the parameters and resend a new request. So we had just changed the DevTools HTML organization to the Mozilla one, and I was able to see all the Mozilla repos on GitHub, which looks interesting, but there are quite a few of them. So let's open the request in a new tab. You can do that by clicking on a log entry and clicking on the Open a New tab. And it takes us to the Json Viewer. This view is activated when you try to inspect a page with a header with a content type, a JSON content type, basically. It should have the same themes as you define in your DevTools settings, so you don't strain your eyes if you are used to a dark theme background. The nice thing, especially when dealing with GitHub APIs, it seems that links are automatically transformed into actual HTML links. I can navigate through endpoints. So here I can inspect this Zamboni repo and see what it's about. Okay, that's it. Well, almost. Sorry, Julian. I want to highlight a few things that were not made by the DevTools team, but that can help developers doing their jobs. First is web extension support. Daniele talked about it. The web extension team did a great work, and most of the Chrome extension in the DevTools worked also in the Firefox DevTools. So you can have React or Redux or Angular DevTools right into Firefox, basically for free. So is the website I was switching to React with the React DevTools. Second thing is Firefox Screenshot. Daniele talked about it also. It's baked in Firefox, and you can copy things directly, the image directly into your clipboard, and then paste it into Slack or Sketch, so you don't have a huge number of temporary files on your desktop. And the last thing, it's multi-icon containers. It can be very handy for developers because if you want to inspect multiple roles on a given web application, you don't have to log out and log in again with a different user. And you can have multiple containers for example, a simple user role and an admin role and stuff like that running in the same browser side to side. Super helpful. So this time it's really it. Thanks a lot. Listening to me while being hungry, I know it's difficult. Please come and see us today. Tell us about your bugs on the DevTools or your IDs. Lots of things were added because some contributors, some people went to us and said, hey, it would be rad if ... We don't know what all the different cases you are experiencing every day are. So you can also reach us on Mozilla IRC, on Slack, on Discord, on Twitter. Thanks. Does anyone have some questions or requests?
There was a lot of problem this morning, but now it works. See the mic?
Yes.
Should I put it in your pockets?
Where is my... yeah. I want to clone it, but where is my mouse? It's here? No, it's here. Yes. Okay. Yes, perfect. Good.
So, you're all set.
I'm all set.
20 minutes work for you.
Yeah, I think so. Yeah. I think we can start maybe now.
So let's give it 1 more minute and then we can start. Okay, thank you. I'm going to ask you to quiet down. Maybe try. I'll give you 1 more second. No? Okay.
Hello, everybody. Okay.
Okay, so thank you, Nicolas, for the console and the network and all that goodness. And Julian is going to talk about the Perf HTML and the Perf Inspector. I'm going to leave you with that. Enjoy.
Hello, I'm very happy that you're here at lunchtime. It's probably hard on you for your stomach, but hello. So today I will talk about with you about Perf.html, which is a profiler. What? Sacré. I need to speak less loud, maybe. Okay. Yeah. Is it better? Is it better? Okay. So I'll talk about the Gecko Profiler. That's profiler that is inside Firefox. We'll get into in more detail. So where is my data? Okay. Maybe. Okay. You don't have any information about me. That's okay. So that's me with cool glasses. I'm in Mozilla for 5 years, and I work on the profiler for 1 year. Probably adjusted to the French accent already with Nicolas. So today I'll explain to you what is a sampling profiler. So that's what the Gecko Profiler is. And we'll dive a little bit into details about what are code trees, what is a timeline, what are markers, and maybe if we have some time, we can try to analyze some profiles. So first, a sampling profiler. Sampling profiler is something inside Firefox that stops your Firefox every milliseconds, or the interval is, you can configure it, but 1 millisecond by default, and look at the stack. The stack is the order of functions that were called to at this specific moment in time. So we do that for every thread and every processes, and then we can capture all this measurement to merge it into a profile that we can analyze. And we merge the stacks into a code tree. So that's a little bit of jargon words that technical words that we use, but that are important to understand. So maybe a quick example for you. Here you can see there is the function A at the end that we call directly, the function A at the top called B, the function B called C, the function C called do work, and do work does very useful work, that is a loop that takes a very long time just for the example. So what happens is that every millisecond we look at the stack. Can you see that correctly? Yes. We look at the stack, so here every millisecond is the same stack because it's a simple example. And the first millisecond we have A that call B, that call C, that call do work, and the same for everything, for every millisecond. And we merge that into a code tree. So the code tree says that A, B, C do work, and we can see on the right the actual time that is spent inside this function. So running time is the time spent in this function, and self-time is the time spent by this function. So we can say A, B, E, C, and C do nothing actually. They just call do work. So that's why running time is 0 milliseconds, but we actually spend time inside all these functions, so we spend 6 milliseconds in them. But the last one, do work, its self-time is 6 milliseconds. It means that the actual work is happening there. In the profiler, it looks like it. So on the top, you have the timeline. Here, there is not much. There is only one stack. But you can see a tree. That's how we display the code tree. And so the first line is the actual HTML file, because it's where everything starts, right, on the web. We start on the global scope. We call A, then which call B, which call C, which call do work. And on the left, you see the actual time that happened when I run it. So it was 94 milliseconds here. And you can see that do work. For do work, the self is 94, but all the others, it was 0. So that was a very, very simple example. So what happens if we take another example? So here, I have A, B, C. C has a loop that called do nothing, and do nothing actually does nothing, all right? So what happens here? Every millisecond, we look at what the stack is. So it's A, B, C, do nothing, okay? But actually, in the code tree, we don't see do nothing. What happens here? What happens is that because we sample only every millisecond, actually, when we call do nothing, it's between these milliseconds. The actual work is actually in C, because that's where the loop is. So that's a fundamental problem with a sampling profiler. We miss data. Sometimes you get a code tree and you see, okay, I don't see this function. Why? Because it just happens very briefly. Even if you call it a lot, if you do nothing in it, or if it takes less than 1 millisecond, you might miss it. And that's something that you need to keep in mind when you analyze a profile. But here there is something slightly different. Here, I'm doing work both in C and in do work. Okay? So we'll get the same thing, the same code tree, but the running time, the running time are the same. So in reality, what happened here, for C, the self time was maybe 1 or 2 milliseconds. We still spend some time in that function, but the most time is actually doing do work. But we actually have the same code tree as in the first example, even if the code was slightly different. The difference was that do work was called several times, okay? But we still see it only once, because what we do is we merge the call stack. So it's not because you see a function once that it's been called once. It can be called a lot of times. What happens is you'll get the same call stack, so we merge that in one call stack so that it's easier to analyze. You follow me? It's okay? It's very simple and in the same time very complex. So more complex code now. Don't pay attention to the highlighted line yet. It will be for later. It's more complex. It's just more function calling, more functions. And what's especially interesting here is that the function f, I think, the function f is called in 2 different places. It's called in C at the top. It's also called in H at the bottom. And f itself calls G, okay? And f and G both have very expensive loops, and E as well. So the goal is to show you what happens when you call the same functions in different ways, with a different call stack, actually. So we have, so it's very short here, but you get the idea of 3 samples every millisecond, so every time a different call stack. First time A, B, C, D, E. I can come back here. A called B, B calls C first, C calls D first, D calls E. And then C will call F. So that's what we see here. Second stack is A, B, C, F, G. Okay? And the third stack we have is A, B, H, F, G, because B called H, H called F, and F called G. So we have 3 different stacks, okay? Because that's for code. And so what we do is we merge the stacks together, but of course here we have a more complex trees because that's how code is. So to make sense of this code, we get the code tree that is on the right. And in the Perf tool, we get something like that. We have the same tree in a tree-like structure. And something interesting, so you remember the highlighted line? It was F, and you can see that F has a self time of 66 milliseconds here, while its running time is 135. It means we spent half of the time in F also doing something, and then we spend half of the time coding something else that does other work. So yeah, that's basically what a code tree is. It's a representation of how your code runs, and in a way that makes it easier to analyze. So here it's already ordered, actually. It's already ordered in the order of the functions that take the most time. You can see on the running time left, it's roughly ordered already. So, so when you see a line of A that called, what do we have here? B called C and H. C, we spend the most time in C and then in H. It doesn't mean we code C first and then H. It just means that C was more important. So we have a tree that is already ordered by the time we spent in functions. And we have another tool to help with that. Because here it's ordered from the top, but we can also invert. Invert means we look from the bottom of the stack. And here we see that G is actually the function where we spend the most time. We spend 138 milliseconds on G itself. But G, if you remember, here, G is called in two different places. It's called, you have it in the middle here, and you have it at the bottom. It's called in two different places, so it's difficult from this view to see what is the most expensive function. But once we look it from the other side, and we merge it differently, we can see that actually we spend the most time in G. It doesn't mean we spend the most time in G once. It can be different times. But that's probably a place where you would like to optimize your code, because that's a place where we spend a lot of time. That's why it's also a bit of note, it's sometimes difficult to analyze the profile for some code that you don't know. Like if you run it on Twitter, you will get some code that is obviously obfuscated. And it's difficult to make a sense of the code if you don't know the source code. So it's best if you work it on your code, that where you have the source code, you can look it, because it just shows you measurements. It doesn't show you how the code is actually coded. For that, you need to use a debugger or things like that. So if you know your source code, that's useful to analyze your own source code. Okay. So finish with the code tree. I can stay a little bit on that. How much time do I have? 7 minutes maybe? Okay. Roughly. There are more tools in the code tree that we can do. I won't show it into more details today. You can merge functions together. You can, if you have a recursion, you can merge the recursion into only one line. So there are useful things that you can do with this that I won't show up now. The timeline. So the timeline, I will show you an example maybe of a real timeline. How is it? It's here. For example, here. On the third line here. I will maybe zoom in it. Okay. So what's important to know with this timeline? Because it's easy to think that, okay, maybe the CPU usage or the memory usage or I don't know, the FPS. It's not like that at all. It just represents the stack. It means that if it's flat, the stack doesn't change. The stack, again, the order of functions you call. But if you have changes in this timeline, it means that something happens. So that's where it's important to focus, when there are changes actually, because that's where something happens. When you have long flat things, it means also that you can have one function that takes a long time. So both are important actually. Okay. So that's the timeline. Where is my, okay. Markers. Markers is something interesting too. So as I explained earlier, Gecko Profiler is a sampling profiler, but the markers helps overcome the limitations of this, because you will instrument your own code. So in Gecko, we do that in C++, of course, but you can do it in your JavaScript code with performance.mark and performance.measure, and we'll see that in the profiler. And actually, Actually, what I showed here in the example, it's a React thing. In the React development version of React 16, I think in React 15 you need the Perf add-on. You will get a lot of markers to show you how your components are rendered. So here we see, so the first line is connect something because we use Redux, and then there is the actual component. So you see the rendering, how it works, and I think in React 16 it's even better, and I'm pretty sure that in other frameworks you have similar things. But I don't know the others, but yeah. So it gives you a sense of what happens in your program. Because again, you know it. It gives you a sense how much time it takes to do something. So, for example, here for the first one, URL manager takes a lot of time because, of course, it renders all it should run, but it shows you, it points you to the right thing to optimize in your code, and that's the important thing. And in Gecko, we instrumented also the right places, so we know reflows. When there are reflows, that's very important to optimize also. We know when there are garbage collectors. That's something that can really slow down your code if there are a lot of it. There are DOM events, of course. I shouldn't forget that. And we also generate special markers to show where the event loop is stuck at one point. For example, if I come back to my example here, there is a big red line here that helps me spot where the event loop was not working. So I came back to my full profile, okay? And I can look here, for example, I zoom on it, and I can really see what happened during this time where the event loop was completely stuck. Usually, if the event loop is stuck because you do too much JavaScript, or your reflow is too big because the DOM is complex, or you have tables, or I don't know. There are lots of different possibilities for your application to be slow. But that helps you focus exactly on the right spot already. So what's good with markers is that you never miss them. It's not like a sampling thing. It's just that if you put a marker, you will get it in the profile, even if you don't sample at the right place. So that's why it's complementary to the code tree. So maybe now, because we're nearly at the end, how do you use it yourself? So there are actually two solutions. First solution is the most supported one because that's the one we use the most at Mozilla. There is a website called perf.html.io, perf-html.io, where you can install an add-on. And from this add-on, you will have an icon. It's a web extension, right? And it's a web extension. It's very important. It means that we have actually an API to control the Gecko Profiler. It means you can do web extensions to control the Gecko Profiler, actually. But that's an aside. And so you can record and capture from this add-on. And the second solution is because we just integrated a new performance panel that you can enable from the settings in the DevTools. You can record directly from the DevTools. So I think there are things that we don't do exactly the same. So the first solution, you will get always the full experience, but with the second thing, you can also do things if you don't want to install an add-on or things like that. I can show you some more analysis. I think 2 minutes? Maybe 1. Okay. This one, maybe. Okay. I want my... Oh, is it? Ah, okay, it's there. That's an example of where we have 100 divs, okay? And we will mutate them. So let's see. So I have my add-on here. I will start it. I click on this to do some work. It's not responsive very much. Probably because some work is happening. It's slow, right? Let's capture. Grabbing the profile. Come on. So at the right moment that things don't work, right? Okay, it's there. So with symbolic hitting, it means we try to make a sense from the memory address we have, and we translate that into functions and methods. So What interests me is the first, because at the end is when we capture, so it's not really interesting, so let's focus on this. Oh, big red thing in my content. I will show it. What happens here? What do you think happens? I will focus on this here a little more. Maybe look at the marker table, marker chart. Steals, reflows. Oh, there are a lot of reflows here. Maybe the call tree. Look at JavaScript. Maybe I will look at JavaScript only. Okay, JavaScript only. There is this function, generate letter, that takes some time, but mutate DOM itself takes like 100%. Okay, that's a lot. And when I look at the full thing, so I'm here. So that's what's not so easy with this, is that it's very targeted to Gecko developers at the moment. It's not very easy for web developers, so you need to use it a little bit to understand what's important and what's not important for you. But we plan to collapse better the C++ part so that web developers can see it better. See here, get bounding client rect. That's the one I was looking for because I knew it was there. But there is get bounding client rect that is probably triggering a reflow. So maybe we can look at the code. Where is it? It's there, okay. Let's look at the debugger. Wow. You don't see much here, right? Okay. Indeed. We were calling get bounding client rect after changing something, so it's not very good. So it was a very simple example. I knew what I was looking for, so it was easy. But it's not always easy to analyze profiles. It takes some time. 2 minutes is very small. But I hope I gave you I gave you some that we wanted to try it now for real. And I'm here if you want some more explanation and some more demos. Thanks to my coworkers, etc. And thank you for your attention.